So the major virulent factors for the pets is just two large protein toxins. Okay, therefore the major target, for our vaccine, okay, is actually the two toxins. Okay, we generated a chimeric fusion protein, okay, covering immunodominant domains, okay, of one toxin called toxin A, and another toxin, toxin B. So we just fused part of toxin A and toxin B and into a fusion protein. But we want to make sure it's toxic, the fusion protein. Therefore, we made amino acid, point mutations to knock out the toxicity of toxins. So that's the component the vaccine we generated. And also in terms of the immunization rules, okay, we based on this chimeric protein, we are collaborating with the different groups, okay, to use different platform for oral or mucosal immunization. So we are using a nanoparticle, okay, to encapsulate the fusion protein for oral immunization, okay, because protein can be degraded in the stomach, okay, when you give immunization through the oral routes. Okay, that's one approach. We are trying to use nanoparticle to encapsulate, to protect immunogens, okay, which are proteins, okay, for oral mucosal immunization. So the second approach, we are using a live vector, okay, the live bacterium, okay, the good bacterium, not the bad bacteria, okay. So as I said, the major virulent factor for the C. diff is just two protein toxins, okay. If the pathogens don't produce toxins, they are not pathogenic. They will not cause symptoms, okay. So therefore, one approach we are using, we just use non-toxigenic strains. So these strains don't produce any toxins, okay. Therefore, they will not cause any symptoms, okay. They can be considered commensal bacteria or beneficial bacteria, okay. So we are using this non-toxigenic C. diff strain to carry the chimeric protein, fusion protein, okay. And so with this immunogen, we hope, okay, so the vaccination not only can protect, okay, our body against the toxins, okay, to neutralize the toxins, and also the immunogens, the live non-toxigenic strain can compete, okay, with the pathogenic strains, okay, because they're both C. difficile, okay. They will compete each other in the colon, in terms of colonizing in the colon, okay. So with this, I think the toxin can not only protect target toxins, okay, to neutralize the toxins, can also reduce the transmission of the pathogens. We have two animal models, okay, the mice model of a C. difficile infection and a hamster model of a C. difficile infection. So we evaluated this vaccine candidate in both animal models, okay. And actually in mice model of infection, the vaccination of mice with these immunogens, including the protein immunogen and also the live vector immunogens, so provide full protection, okay, against infection with the hypervirulent epidemic strains, okay. This results in mice model infection. So it's so we monitor several aspects of the infection, okay. We monitor of course the diarrhea, okay, the major symptoms, and also the weight loss, okay. When animals like humans, they're going to lose weight, okay. And also we monitor, of course, the mortality, the death, okay, in terms of the death rate and also the diarrhea percentage and also the weight change, the 100% protection. And after immunization, animals, mice, don't develop any symptoms of the inflammation, and no all animals survived, and no any weight loss actually, right? Because for vaccine development, so minimum, okay, we need to have 2 animal models, okay, and also hamsters are very sensitive to toxins, to the C. difficile infection. Just 100 bugs, okay, the spores, because they can kill the hamsters. So it's very sensitive. That's why the hamster model is a very good model to evaluate the strengths of the vaccine candidate and the immunization. So the hamster model is also provide a significant protection. So the next step we're going to in terms of the vaccine development, right? And so we're going to further, okay, to develop new vaccine candidate to enhance, okay, the immunogenicity of the vaccines. Okay, we are including the colonization factors, okay, and in the fusion protein. And we are also including the Salmonella flagellum C, okay, so in the fusion protein as a part of the fusion protein, because Salmonella flagellum C is a known potent adjuvant, okay, which can enhance the immunogenicity in general significantly. Okay, so we already generated all these new generation of fusion proteins, and so we're going to further evaluate them in animal models, and we're also going to put them into the non-toxigenic C. difficile strains as live-based vaccines. So in terms of the target population, and we also need to think about the disease, okay, and so actually the elderly people, okay, so with around older than 60, they are easily they are susceptible to infection, okay, for many reasons, because the compromised immune system, and also they have some conditions treated by antibiotic treatment, leading to disruption of the intestinal microflora, okay. So yeah, there's the target population, and also currently the standard treatment, okay, for the infection is still the use of antibiotics, okay. So why the antibiotics effective, okay, still effective, can eliminate the disease symptoms, okay, but the symptoms may come back in 2 to 3 weeks or months, okay, a recurrent CDI. Okay, what? Because of the antibiotic treatment is going to further, mess up and disrupt the intestinal microflora. Okay, why? That's why the disease recurrence rate is very high. Okay, so in terms of vaccination, I think the target population is elderly people. Okay, with the age, advanced age, 65 year older. Okay, and also the patient, okay, who already developed 1 episode of the C. difficile infection. So when they develop first episode infection, I think it would be if they get immunization in time, I think they'll be protected for developing the second, even multiple episodes of the infection, to stop the recurrence, because once the disease recurrent, so it's very challenging to treat, okay. And that's why currently the most effective and the approach is the fecal transplantation to treat the recurrent C. difficile infection. Okay, so it's very difficult to treat. That's why, in terms of target population, it should be the elderly people with advanced age, and also the patients who already developed the infection.